Right, so there's an example. Now, this here is a point of contact. Do you agree with that? Okay, so what are the tangents here? I've drawn in 2 points of contacts. Point P and point T are points of contacts. And then the tangents, I've got WP as a tangent, PS as a tangent, SW as a tangent, SQ as a tangent, or even TS as a tangent if I only consider this side, or TQ as a tangent. Right, so there we go. Now, let's see. Let's start with a tangent. And let's get our highlighters. Highlighters worked well earlier. So there's a highlighter. Well, there's a tangent, WP, and there's a chord. Do you see that? There's a tangent and there's a chord, right? Now the angle between that particular tangent and that chord, I'm going to make that angle green. Do you see that angle is green over there? Right? That angle is equal to the same angle subtended by these 2 points on that chord, from there and there. And now I'm going to draw lines and I'm going to say, well, okay, I go from there all the way here and all the way there. Does that make sense? Now that there, this angle is equal to whatever angle I construct that starts on those 2 points between that chord, point of contact to the end of the chord, all the way anywhere in the circumference. So if I went and I did that, and I did that, then this angle, if I want to call that alpha, this will also be alpha, this will be alpha. Start on that point, go to the circumference, start on this point, go to that same point, then that is also alpha. Do you get the idea? So I'm going to clear it. So from here we can say that clearly P2 is the angle that is between the tangent PW and the chord PB. That is equal to T1. Right. And my reason is tan chord. Right? What tangent are we considering there? PW. That's the tangent PW. Okay, let's get another one. Let's see. Let's take the same tangent. Do you see that tangent over there? I'm going to consider the tangent WP, but I'm going to consider PT as a chord now. Now that's my tangent, that's my chord. The angle between my tangent and my chord is P1 plus P2. So P1 plus P2 is the angle between my tangent and my chord. So I'm still interested in the tangent PW, but now I'm interested in the chord PT. So I'm going to say tangent PW, chord theorem. This is my reason, right? And I'm interested in the chord PT. Now this is the segment we've got, but now we're interested in the angle that it subtends in the other segment, and that's the other segment over there. Do you see that? So what does that tell me? That tells me P1 plus P2, that's an angle, is equal to angle K. That's the angle over there. That's the same angle, right? So P1 plus P2 is equal to angle K. Are there more? Well, let's see. Let's see. Let's take the same okay, that's a bit complex. Let's take the same tangent but consider the other side. Right? There's the other side. And there's a chord. Now the angle between that tangent and that chord, that angle is angle P4. If you can see it clearly over there. That's a P4, right? Now P4 is equal to, now again, that's tangent PS. Tangent PS. Oops. Let me just erase that. We're interested in the tangent. This again, we're working with tan chord theorem here, right? And the tangent I'm interested in is PS, and the chord I'm interested in is PK, right? Now, the angle that is subtended by PK to the circumference from those 2 points, from that point over there, right? Do you see that? Let's get a red pen. From that point over there and that point over there, right? That points go to the circumference in such a way. Do you see that? Back to those 2 points. Do you see what I'm doing? Now the easy way to do this is to really just take your finger and you take it at P and at K and you go to the circumference. So I mean, if P4 is exactly the same as T3, right? Now if I were to construct another angle over there, all the way there, and I call it angle cow, then that P4 will be the same as angle cow 1, if you wanted to call it cow 1. But anyway, so we get P4 equals T3. I've already done P2 equals T1. P1 plus P2 is a big angle there, that's equal to K. We've just done P4 is equal to T3. Right, let's do another one. Let's take the same tangent, PS, and consider this chord. Right. So we now have the angle there is angle P3 plus P4 is equal to the angle subtended again between these 2 points in the other segment. There's the other segment. Do you see that? There we go. There's the other segment. Is equal to angle B, and my reason is tan chord theorem. Right? The tangent we're considering is PS, and the chord we're considering is PT. Okay, and there we go. That's equal to angle B. Okay, so I've got P4, I've got P3 plus P4. There's nothing given to us on that side. Right, so I've done everything on this tangent. I've done P1 and P2, P3 and P4. I've done P2. I've done, yeah. So let's go to the other tangent. So here's also a tangent. This is a tangent TQ. Let's start on that side. And there's my chord. Okay, so from here you can already tell me now. Things look like that, right? I'm going to say it's the angle between that is the same as this angle here because it's subtended between these 2 parts, right? And you should take your fingers or draw it in, if you must, like so, right? From that point to the circumference. If I were to do the same thing here, it's also going to be equal. So T1 equals P1, and my reason is the tan chord theorem. The tangent I'm considering is TQ. The chord I'm considering is TB. Okay, let's see what else have we got. Let's say we've got T1 plus TQ, right? So I'm going to take the same tangent on that side. I'm going to take this chord now. And then the angle between that is T1 plus TQ. I'm sorry, T2. And that is equal to really angle K. Okay? That's equal to angle K by reason of the tan chord theorem. And the tangent I'm considering over here again is TQ, and the chord I'm considering is TP. Okay, let's see what I can do now. Right? And again, remember those are the 2 points. If I take that to the circumference with my fingers to the same point meet up there, then this angle here must be the same as the angle that was made between the tangent and the chord. Okay, so the last ones we want to do is let's get a pink highlighter. Pink seems to be a nice color for the evening. TS is an angle. TS is a tangent, and TK is a chord, right, on the circumference. In the circle, from the one point in the circumference to the other point in the circumference. Yeah, okay. And there's my angle. So I'm going to say it's angle T4. That is equal to any points that start on that same 2 points. And you're going to see there's my 2 points, there and over there. And I go like this, and I go like that, and there's my 2 lines. Right? That's P3. T4 is equal to P3. And again, the reason is the tan chord theorem. And the tangent I'm considering here is TS, and the chord I'm considering is TK. Okay? And if I were to do that, then, and I call this angle donkey, then angle donkey is exactly the same as T4, or the same as P3 because the angle's on the same segment. Okay, so let's take TS again, and consider this chord. Now what's the angle between that chord? Well, it's T3 plus T4, because those two angles together give me the big one, and that there is the same as angle B. And you can guess the reason. Apologies for that, the phone call just came into studio there. Anyway, so as we mentioned that the reason is the tan chord theorem. The tangent I'm considering again is TS, and the chord I'm considering here is TP, and that subtends, the chord TP subtends the angle B, right, in the other segment. And that's the tan chord theorem. Well, in a nutshell, as you've seen, that's the tan chord theorem. So what we're going to do now is we're going to move on with question 10.2.2.